System of equations. Whoa, one of my favorites. I love it. I just love it. I hope you do too. Okay, it's used to find the answer to a problem with two variables or more. So this is an example of a problem that you'd see. We're not going to solve this one right just yet because we don't know how. Let me box it in a little bit better. So 3x plus 2y equals 9, 5x plus y equals 7. Whoa. Alright, so let's get some information about it first. There are three ways to solve it. Substitution, which we'll do today, elimination, and graphing. Those are the three ways. There are three types of answers. One solution, which I drew a picture of all of them. No solution, which is parallel lines, and infinite solutions. It's the same line. So if you're thinking about it graphically, or some of you guys are visual learners, that's what they look like. But there'll be an answer for this. So one solution would have one x value, one y value. No solution, you can't find it. An infinite, every value works. So let's go over some of this. Substitution method. What is that? What it is taking a variable and substituting it. In this problem, x and y are x equals, both x's equal the same number and both y's equal the same number. So what we're saying is, since this problem 3x plus 2y equals 9 and x equals y minus 2, I can take this, since that's what x equals, and I could put it in here. Oops, let me pause it here. I could put it into that x. Let me show you a quick problem real quick. If I have this, and this was in the do now, I take this 3 and put it in for y. So my problem is now 3x minus 3 equals 12. So I can solve it and plug it in. That's a number, plus 3, and I have 3x equals 15, and I divide. So with the number, we know what to do. The problem is, without the number, when it's variables, we get confused. But look at it, it's the same thing. Here, I'm doing the same thing. I know x equals y minus 2. It's not a whole number, but it's something. So let's try this. So I'll rewrite my problem 3. Now, instead of putting x, I'm going to put y minus 2. And recopy everything else. Plus 2y equals 9. Alright, I just moved that over a little bit because I'm going to run out of room. So, that's plugging in for x. Now I multiply or distribute the 3. So I'll get 3y minus 3 times 2, 6, plus 2y equals 9. Well, now I have to combine these terms. Alright, so that becomes 3 plus 2y. 5y minus 6 equals 9. Now I add 6 to both sides. We know how to do this part now. So 5y equals 15. And now I divide by 5, and y equals 3. So y equals 3. Now you have to find x. To find x, plug it back in. Find x. So I know that x equals y minus 2. So I'm going to plug this number in to y. So x equals y, we just said was 3. And just so you guys don't get confused, I'll put all the rest in red. So x equals 3 minus 2, so x equals 1. So my answer is x equals 1 and y equals 3, or we could write it in coordinate pairs, which is 1, 3 is my answers down here. Okay? I'll pause here. Let's try one like this. Now, it's a little different. I don't have a variable alone, which I need. So, let's get that alone. Let's solve for y. So y equals 6 minus x. So let's use this. And plug it into here. So let's rewrite this. Five x minus 2. What does y equal now? Y equals 6 minus x. 6 minus x. So I plug that in, equal, and then it equals 1. So let's distribute. So 5x minus 2 times 6 is 12. I'm distributing. That's 12 minus 2 times minus x is plus 2x equal to 1. So let's combine our like terms. I messed up, guys. That was supposed to be a 16. I wrote the 6 and I forgot. Okay, so let's just put that 6 in there. So I combine those. 5 plus 2 is 7x minus 12 equal to 16 now, not 1. I don't know why that was there. Now I add 12 to both sides. And I get 7x equal to 28. And you know what to do from here. I divide by 7, and x equals 4. So if x equals 4, I go take this and plug it in there. So y equals 6 minus 4, y equals 2. Now it works. You could have done it the other way with the wrong number, but it would have been a messy answer. So my answer would be 4, 2. You can just write it in coordinate point form, okay? I'll pause here. I'd like you guys to try this.